So let's look at this worksheet 16. Okay, we didn't manage to complete last week. So take a look here. Circuit diagram shows two batteries, okay, connected to 4 bulbs. All right. 1 minute. Sorry, just give me 1 minute. Okay, what is happening here? Oh, yes, Alicia. Yeah, Alicia, you have the worksheet 17, and I think it's not just you, another student like Nadra, because you are on the trial lesson today, right? Yes, so you don't have this worksheet. This worksheet actually was from last week, okay? Because we are doing a lot of learning the last 2 lessons, okay? And Miss Day doesn't like to rush through all the questions. That's why they are doing it now. All right, Alicia. So don't worry, you look at the question, okay, and then you listen to the explanation. If they are participating, you listen to what they say. Okay, that's most important. Understanding is more important than copying down everything. All right, Alicia? Okay, thank you. Now, let's see. Come back to this question. So when one of the bulbs fuses, the other 3 bulbs still remain lit. Which bulb is this? So the way to do this is you are going to look at, okay, the individual, you are going to look at the individual bulb here, right? So let's say I try to make this particular one fuse. So when it's fused, there is actually an open circuit, right? Correct? Y'all know this, So how do you check whether electricity can flow through the other bulbs? Look at the paths that the electricity can flow. So if I were to change the color, okay, there is this one path here that electricity can flow, right? Okay, so I will be going this way. When it comes to this point, can the electric current flow? When it comes to this point at bulb A? No, because this is an open circuit. So this is not going to happen. All right. So if you're going to check if it's going to travel to the other side, it's not going to happen as well. So if, let's say, bulb A fuses, what happens is all of them will not light up. Clear? Because there's an open circuit, electricity can't flow. Let's try B. Okay, let's try B. Imagine this one, okay, is fused or blown. What happens? Yeah, see how I saw your answer. Okay, but I'm teaching everybody how to approach this question. Okay, some of them have not done this topic yet. All right. So let's say current starts flowing this way. Okay, can pass through, right? Right. Here still can pass through, right? Okay. So this part here forms a complete circuit. Can you see that? It's a closed circuit. That means these bulbs will light up, right? And then obviously B cannot light up. Yes, Evan, you're right. The others will still light up. Okay, there is another road. It's not road. It's actually another path. Okay, Evan, where are you? Too many of you already. I can't find his face suddenly. Okay, Evan, take note. Okay, there is another path for the electricity to flow. Very good. Okay, anyone cannot understand this? Gordon, it doesn't matter because at this level, you need not know how it flows. Okay, so Gordon is wondering, how come Miss Day actually started drawing the flow of the current here, right? Okay, at your level, you need not know. You want to draw from here also can. All right, so long as I can actually see that it is connected completely. All right, Gordon? So you don't worry about how the current flows. I'm just trying to see if there is a complete path. Thank you for asking. Okay, so let's say if it's C, okay, I'll just very quickly go through for part C, for bulb C. Okay, so the current flows. Okay, it can flow through here, right? Okay, good. That means this will light up. Okay, then let me change. Right, my answer is out, but that's fine. Okay, let me change another color for my pen. Okay, so if I draw this particular direction now, do you think electric current can flow through here? No. Okay, it is not possible. Why? Do you all know why when a bulb fuse, the current doesn't flow? Or when the bulb is blown, the current doesn't flow? Do you all know why? Okay, think about it. Okay, we talk about how a bulb works, right? So I try to draw a light bulb. So this is the metal casing, and then you have the metal tip, and then you have the bulb. This is the glass. Right now, not bad, right? My drawing today. Okay, so this part is the filament. So when a bulb actually blows or is fused, what happens is the filament is already burnt or melted or something like that. It can no longer allow electric current to flow through it. Yes, Yun Shen, please go. Okay, so you all must remember this. So when the bulb has blown, it means the filament, okay, is burnt. Okay, it can be melted, but no matter what, it already cannot allow electricity to pass through it. Yes. Yeah, right, Gordon. Okay. Yep. Okay, so the current that flows through is too high. That's why it caused that problem, Gordon. Okay. So that's why it will cause an open circuit. So our answer is B. I need not do for D because it's the same result as bulb C. Question 2, John connected 3 objects, PQR, into a circuit as shown in the diagram. When he closed both switches, only B1 and B4 lit up. So I'm going to draw like this, okay? You know, like our application, right? FAT, when the bulb lights up, you see these lines. So I'm going to draw that. So you know that only these 2 bulbs light up, right? So what does it tell you? That means, okay, electricity can flow through this particular path. It can also flow through another path, which is the path here. Okay. Can y'all see? I actually used red ink and purple ink to draw the complete path. That will tell me, okay, that will tell me this must be a conductor. And when I put a conductor, I mean electrical conductor. All right. Q must also be the electrical conductor. What can I say about R? Current didn't flow there, right? Why? Why is it that no B2 and B3 didn't light up? It has something to do with R. R is a, let me see your mouth. Yes, very good. Okay. Giselle, I saw that you're not telling me the right thing. Are you? Your mouth anyhow move. You have to type in. Can only type in from now on. Okay. Yeah, not a conductor. But the correct term, try to avoid not a conductor. Yes, that's right, Gordon. You mean now then you realize it, Gordon? Insulators, there are 2 types. Heat insulators, electrical insulators. Try to avoid using the term bad conductor. Okay, or poor conductor. Because when you use the word poor conductor, it seems like it can still conduct, right? It's just that it conducts very little bit. So we try not to say that. We will use the term, yes, correct, insulator. So everybody, remember, use the word electrical insulator for electricity. But if you are doing the topic on heat, you should mention heat insulator. Clear? Right, so which is our answer? Of course, you know, answer will be C. Silver is a conductor, steel, conductor, plastic is an insulator. Right, good. Next one. Anna set up a circuit as shown. It consists of 3 bulbs, A, B, C, as well as 3 different materials, X, Y, and Z. Do you see that this is common question? The last 2 worksheet, or should I say, sorry, the last worksheet is also testing you a lot on insulator and conductors, right? Yeah. So be very familiar with all this. All right. When the switch is closed, only bulb A did not light up. Now they are talking about the bulbs in another way. Previously, they said light up, right? Now it says did not light up. Okay, so if let's say it's just A that didn't light up, that means this 2 will light up, right? So in the exam, for me, okay, I'm a visual person. I'll take pencil to draw things like that. Okay, so I will remind myself B and C will light up, right? What are the possible reasons for this observation? Okay, is it true that bulb A could have fused? Is this right? Could have lah, maybe lah. Right, not Sam? Sam just now say no. Then after that, yes. Okay, now, so it is possible that bulb A has fused. Bulb A has already blown. That's why it didn't light up. Let's say Gordon says it cannot travel upward from the battery due to the open circuit in between. Where got open circuit in between? Which one? Which open circuit in between? Like a open connector. Where is that connector that you're talking about? The switch. But they say when the switch is closed. All right? Because now I cannot push the switch down, right? Okay, Gordon, yeah. So, okay, maybe I just draw something like that. It's closed, okay? It's closed, huh? Heat is fine. Nara, you're asking a good question. Okay, poor conductor of heat is fine. All right. But we will try to stick to insulator. Okay, Nara, good question there. She's asking, okay, let me share with you all. Nara is asking, when she was learning about heat, her teacher used the term poor conductor of heat. She asked, is it wrong? It's not wrong. For heat, right, we have actually a poor conductor like air. Does it mean that it totally does not conduct? It still will conduct. Okay, when it's just slow down the heat loss, okay, it just slows down the heat gain, something like that. Natra, you understand what I'm saying? Respond to me, okay? Type in yes or no. All right. It's important that you understand, Nara. Good. Thank you for asking. So it's important that you clarify if you're unsure. Okay, good. So is it possible that material X cannot conduct electricity? Cannot conduct electricity means it is an electrical insulator, right? Possible. Yeah, Gordon, I know you want to say it. All right, so this is an insulator, it's possible, right? So if you have, let's say, your eraser connected there at that portion of your circuit, can electricity pass through your eraser? No. Yeah, that's why A cannot light up. So they say batteries are not connected properly. Can these be the reason? Let me see who will say yes. Cannot, right, Evan? Okay, cannot, because if batteries are not connected properly, will any of the bulbs light up? No. Yeah, I like how all of you are giving me the signal, shaking your head, nodding your head. Well done. Okay, so last one. Materials Y and Z are conductors of electricity. Obviously, yeah. Thank you.